Hi, in this video we're going to have a look at solving cubics, and that almost always means finding values for x such that an equation is true where the degree of the equation or degree of the polynomial is 3, i.e. the leading term is an x cubed term. So I thought there was nothing better to do than maybe just take an example from each of the questions in 6D, which are all about cubics. The whole idea, by the way, is we'll build on this in the functions unit, but if we had a set of axes with a cubic, the cubic function is like this, or it might be like this, or it might be like this. So there might be 3 solutions, or 1 solution, or 2 solutions. And by solutions, we simply mean that when the function is equal to 0, there are 3 or 1 or 2 places where where the graph hits the x-axis. So when we talk about solutions, we're saying values for x such that y equals 0. Okay, I'll get rid of that because that's just by the way, that's what we're doing it for. Let's have a look at solutions. And I'll just zoom up so you can see example 1 here, and away we go. In almost all cases, what we are going to do is we're going to apply the null factor law in order to solve. So in the case of example 1 here, the cubic has already been factorized into 3 linear factors. If I expanded this, and I won't do the full expansion, but you can see here taking the x term, x times x times x, will give me an x cubed in the expansion. So that's why it's a cubic. But in terms of the solution, it's just like by the null factor law, x minus 1 equals 0, so x equals 1. X plus 2 equals 0, so x equals negative 2. And x minus 4 equals 0, so x equals 4. That's good enough. If you wanted to spell it out a bit more, you could do. Okay, have a look at example 2. X cubed minus 2x squared minus 8x. Now, you might be tempted to straight away go into using something like the factor theorem in order to find a factor. But I want you to remember, please remember that you should always look for a hookup. So is there a highest common factor first? And in this case, there is. X is a common factor. So if we take x outside first, we end up with x squared minus 2x minus 8 is equal to 0. So I've already got a factor of x. And now we just need to look at the inside of the bracket bit and see whether we can factorize it more. And you can use whatever method you want to, reverse box method, or just by inspection, which simply means it's a basic monic trinomial. Are there 2 numbers that will multiply together to give me negative 8? They'll add together to give me negative 2. And negative 4 and positive 2 will do that. Negative 4 times 2 is negative 8. Okay, I'll draw it in, but obviously you just think this. Negative 4 times 2 equals negative 8. Negative 4 plus 2 equals negative 2. So negative 4 and 2 are the winner chicken dinners. So the bit inside the bracket would be x minus 4, x minus 2 is equal to 0. And then by the null factor law, x equals 0. Don't forget that one. That's the first factor. X equals 4 and x equals 2. Hopefully that all makes sense. Let's have a look at example 3. And for example 3, we've got x cubed minus x squared plus x minus 1 equals 0. So we just really need to use some sort of method in order to try and factorize it. And, factor theorem might be one way you could go. It almost always is. If you ever look in the textbook, it actually gives you a hint. It says use grouping to solve each of the following. So that's a bit of a bonus. And you can. So what I'm going to do is I'm basically going to take the first 2 terms and the last 2 terms. And in the first 2 terms, there's a common factor of x squared. So that's x squared outside of x minus 1. And I've got x minus 1. Oops, I've got the x equals 0. I've now got a common factor of x minus 1. So remember that little shortcut that you can use if you really want to. Let a equal x minus 1. And that will give you x squared a plus a is equal to 0. And then when I take out a common factor of a, I'm left with x squared plus 1, which is equal to 0. Notice my equal signs are pretty much underneath each other. And now I'm going to replace a with what I had before, which is x minus 1. So I've got x minus 1 multiplied by x squared plus 1 is equal to 0. Now, by the null factor law, I'll do that on slide 4, so I'll just zoom out and keep it zoomed out so you can see it. So by the null factor law, I'm going to have x minus 1 is equal to 0, which gives me x equal to 1. That's easy enough. But the other factor is a squared factor, x squared plus 1 is equal to 0. And I'm just going to solve this a little bit more so you can sort of see where I'm going. Therefore, x squared is equal to negative 1 by subtracting 1 from both sides. And then if I try to take the square root of both sides, I'd have the square root of negative 1, plus or minus to be precise, but the square root of negative 1, which does not exist. It does, but it's not a real number. This is this kind of graph here where we've got x equals 1, and then the cubic has sort of moved on like that. So there's only one zero, only one solution for x. So bottom line is, if I take one of the factors and I end up with a square root of a negative 1 or something that does not exist, then you can say there's only one solution, in this case, x equals 1. Okay, so there's three examples for you. I'm going to do some more examples in another video, but I'll just cut this short here so that you can perhaps take this away, have a go at exercise 6D, questions 1, 2, and 3. Check your understanding to make sure that you're pretty solid on these kinds of ones, and then you can return to the second video. We will have a look at some more complex examples. Hooroo!